Hello everyone, today we are going to solve convert a BST to a greater tree. Okay, so let's understand the problem first. So in this problem we are given the root of BST and we have to convert it into the greater tree such that every key of the original BST is changed to the original key plus sum of all the keys greater than the original key. Okay, let's understand it here. But before moving to the this problem, let's get a reminder what is BST it is. So the in BST the left subtree of a node is only nodes with the key less than nodes key, and in the right side it is greater than the nodes key. Okay, and both left and right side subtrees must be a binary subtree. Okay, so this is our BST, and now what we have to do is, if you see clearly that the number of this is the sum of all the keys greater than original key. Okay, so there are 30, this is 30, and all the element here it will be greater than 4. So if you add this 6 and 5 11 and 7 or 8, this will be gonna 7 8 15 plus 11 plus 4. Okay, so this will be 30. Okay, if you see this one, so how we are going this, so this is 30, this whole is 30, and 1, and this is 5 plus 1, this is 36. Okay, so that's how we are going to see. So we have to, what we have to return is, we have to return a node of this where our answer would be like 30, 36, 36, 21, 15, 8, and 26. So we have to return this root. Actually it is the same root, we just change this value. We are not creating another binary search tree and with this value. This is the same BST and we just have to update this value. So how we are going to update this? So let's see. It is known as greater tree. So where we can start? If you see here, this is 8, this is 8 plus 7, this is 8 plus 7 plus 6, this is 8 plus 7 plus 6 plus 5, and then 8 plus 7 plus 6 plus 5 plus 4. Then we are moving this. So if you see clearly, so what we are doing is, we are first iterating here, right subtree, then the left, then right. Okay, so we first finish our right iteration. If right tree is done, then we move to the left subtree. Okay, so let's see how we are going to solve this problem. So the solution would be we are taking one variable. Let's say we are taking one variable sum that is equals to 0. Okay, that is equals to 0. It will calculate the sum of all the keys which are greater than the original key. Okay, and we are going to iterate this BST in such a way. First of all, we are going to iterate the right subtree. If right subtree is done, then we are going to see the left subtree. If right and left both are done, then we move to the root. Okay, so how we are going here is, first of all we are at 4. Okay, so we are at 4, our sum will be 0. Then we will goes to right, here 6, then 8, then 7, then 8. Once we reach 8, there is no other left or right. So what we are going to see, we are going to update this value with sum. So 8 plus sum is 0, that will make it 8. And now we are moving to its left side. So there is no left side of 7, so we are going to see right side. Oh, that means node. So node will be 7, and we are going to update this sum as 8. Okay, so 7 plus 8 will be 15. Now we are going to see its right side. Now we are going to see this. Okay, so what it will be, and our sum will be updated to. So every time we change our root val, we are going to update the sum with the root val. Okay, we are going to, first of all what we are doing is, we are going to do root val plus equals to sum, and then we are updating our sum to the root value. Okay, so now we go to the 6 and here it is 21. So what we are going to do is we are going to it is 6. So 6 plus 15 will be 21. Then we are moving to the left side here. So it is 26. So how it is 26? Our sum becomes 21 and this is 5. So 21 plus 5 will be 26. So that's how we done with this. Now we move to this. We update this. How we are going to update this? So 26 plus 4 and then likewise we are going to update this here. So once we here, then we go here. Okay, we are not updating here, we just go to right, we again go to right, we reach here. Okay, because we have to first travel right, we do not first update root or left, we first update right. After right we go update this and this. Okay, so first we have to update the greater element. So 3 is greater than 1, so we are going to update this. So we have a 30, our sum is right now is 30. So 30 plus 3 will be 33. So it will be 33 now, and then we are our sum will increase to 33. So 33 plus 2 will be 35. Then 35 plus 1 will be 36, and then we are going to move this. So first we are going to move at right, then our root, and then left. Okay, so let's see how we are going to do it in a code. Okay, so let's start with our solution. So this is our code. So what we are doing is, if our we are initializing one global variable which is sum equals to 0, and then in this code we are checking if our root is null, then we are going to return null. Otherwise we go to the right side until we reach the rightmost side of the subtree, and then we are taking this right value and increase, add sum into that, and then we are going to update our sum to the root value, and then we are going to left side, and then we are going to return our root. So let's have a dry run. So first of all we are going to convert, we are going to call our function, let's denote it by f. We are going to call our function f, and root is let's say 4. Okay, and nothing more. Okay, so we call this f4, and it says that it is not null, so we are going to call it right. So we post this and call f4, it will be calling 6. Okay, so it is also not null, so it will call it right. So f6 will call f7, and then f7 will call f8, and then f8 right will be null, so it will return null. So we are not calling it right now. So f8 our right call is done. So what we are going to do, we are going to root update this f8 values to the sum. So right now we are taking our one variable sum equals to 0. So 8 plus 0 will be 8. So it is 8. Okay, then we are going to call its left value. So left value is also null, it will return null. So we are going to return its root. So we return this, we are returning this. Okay, so basically we are not using this return value anywhere, so we do not need to show this return value. Okay, let's see. So f8 is done, it is written. So we go to f7, and f7 right is done. Okay, f7 right is done, f7 left would be null, so it will return null. Then what we are going to do, we are going to update its value, so 7 plus and we update sums to 8. So 7 plus 8, it would be 15. Okay, it would be 15, and then after it would be 15, so our sum become 15, and then we are going to return its root because left is null. Okay, so actually what we are doing is, first of all we are updating our roots, then right, then our root, then we call our left. Okay, if you see here, so our f7 is done, f7 is also done. So we are here. Okay, of the f6 right is done, f6 right is done. Then we are going to update f6 root. So we are going to update 6 plus 15 will be 21. Okay, so we are going to update this as 15, this as 21, and updating sum as 21, and I'm going to call it left value. So we are going to call f5, So f5 will be not null. So f5 call is right value. Right value is null, so it will return null. And left is also right is null. So then we are going to update it somewhere root value. So its root value will be 5 plus it is our 21. So 5 plus 21 will be 26. We are going to update some as 26 and update this value as 26. Okay. Now we go to we are going to check its left value, which is null. So we are going to just return our root. Now this f6 is done and f6 and f5 is done. F6 is done. So we are going to f4. On the f4 we are going to update 26 plus 4 will be 30. We are going to update our sum as 30 and update this value as 30. And then we go to the left value. So left will be f1. So when we go to f1, f1 is not null, then we are going to write going to f2. Then f2 is not null, then we are going to call its right. So its right will be f3. Then f3 right will be null, then it will return null. So we are going to update f3 value. F3 value will be 3 plus 30, it will be 33. So we are going to update our sum as 33, and then we are going to call its left, and which is also null. So we are going to return f3. So f3 is done. We are going to f2. So updating f2 right is done. So we update f2. That will be 2 plus 33. That will be 35. So we are going to update it is to 35 and making this as 33 and this as 35. Okay. So is done. Now let's see left value. So f2 left is null. It will return null. f1 right is done. That is 2. Now update f1 value. We are going to update f1 value. f1 value is 1 plus 35 would be 36. So we are going to update is 36 and going to update our sum is to 36. Now f1 we are going to see f1 left, and f1 left would be 0. So we are calling 0. After calling 0, we are calling its right, which is null, calling it and then updating 0. So 0 plus 36 would be 36. Okay, so we are updating this to 36 and updating this to 36. Then we are checking its left value. Left value is null. Left value is null, so it's written null. So it returned null. So f0 is done, and then f1 is also done. Okay, so now our f4, our left is done and right is done. Then we are going to return its root value, that is we are going to return 4. So this 4 will be written, and we can have a root having value 30 and all the tree values is updated. So yeah, so this is the whole solution. Let's discuss the time and space complexity of this problem. So what would be the time complexity? As you can see that we are going to move each and every element only once. So the time complexity will be O of n. Okay, and this will be our time complexity. And talking about the space complexity, so what will the space complexity? As such, we are not using any extra space, but we are using our call stack. This is the way I am just denoting you that which function is returning, which function is right now calling, which is resume. Okay, so this is done in the call stack. Okay, and at max it will take O of n. You can say it will take log of n. Okay, tell me why. Because it will either take the right side or the left side, not both sides at same time. Because after taking all the right side, it will return all the values and then go to the left side. So the space complexity will be log of n. Okay, and where it is used? It is used by the call stack in our recursive function. Okay, so this is the time and space complexity. And if you understand this solution and if you understand the time and space complexity, do let me know in the comment section. You can check the article and the source code in the description. Thanks for watching.